Okay, we're going to talk about greatest common factor. So we're going to be talking about definition of greatest common factor and how to find the greatest common factor. And we're going to use 3 ways to do it. We're going to talk about the list method, we're going to talk about factor trees, and we're going to talk about the birthday cake method. Okay, so that'll be a new one you probably haven't done before. All right, so the definition of greatest common factor is the greatest number that is a factor of 2 or more numbers. You're going to want to write that down. It is the greatest number that is a factor of 2 or more numbers. Okay, so for example, if we were trying to find the greatest common factor of 6 and 8, you need to find the factors of 6 and the factors of 8. So the factors of 6 are 1, 2, 3, and 6. The factors of 8, 1, 2, 4, and 8. The greatest common is 2. Why are we not circling here? Because it's the greatest number and it's common because both of them have it. Okay? Greatest common, yes. Okay, there's several ways to find the greatest common factor between 2 numbers. Once we go through them, you're going to find the one that works best for you, and that's the one you'll want to fall back on. You'll want to look at all 3 and then choose the one you like the best. One way that we just did, and that was real quick, is you list them. By listing them, you write your number, and you write all of the factors of the numbers. So there's 12, and what I'll usually do is start with 1 and say 1 times 12. Does 2 go into 12? Yeah. 2 times 6. Does 3 go into 12? Yeah. 3 times 4. Does 5 go into 12? No. That's how I'd figure out what my listing is. Find the factors of 24. I'll say, does 1 and 24, does 2 go into it? Does 3 go into it? And then you list the other factor. Once you list them out, you circle the common factors. 2 is common, 3 is common, 4 is common, 6 is common, 12 is common. And then you pick the one that is the largest. Now, that you have to remember, you're looking for greatest, not least. Least and greatest are 2 different things. So if you're looking for the least common, you're looking for something else. Here, you're looking for greatest. Yes?
Is 1 ever a common factor?
It can be sometimes. I mean, it's always a common factor. Okay? So what I want you to do on your whiteboards is I want you to use the list method. And I want you to find the greatest common factor. Oh, we don't have to do that. We already did it. So the greatest common factor is 12. Okay, they did it for us. All right, this is the second way to find greatest common factor. So that was the list method. So after that, you should have list method. This is called a factor tree. Okay? Factor tree is the second way. When you are making a factor tree, you start with your original number, and you list 2 factors that you know of. It doesn't matter which ones you start with. You can start with any factors that you know. In this case, they did 3 and 4. 3 is a prime number, so you cannot factor it out anymore. You don't factor that one down any more than that. 4 is not prime. You can do 2 times 2. 2 is prime, 2 is prime. So your factors are 2 and 3. It's 2 times 2 times 3. If you look over here, you have your other number, 24. 6 and 4. 4 is 2 and 2. 6 is 2 and 3. So it's 2 times 2 times 2 times 3. This is where it gets tricky. You want to look for the numbers at the bottom of the factor tree that they have in common. So if you look here, they have 1, 2, a 2, another 2, 2, a 3, and a 3. Do they have 3 2s each? No. So you ignore that one, and you multiply 2 times 2 times 3, and that gives you your greatest common factor. Okay? 3 would not be the greatest common factor. Don't make that mistake thinking, oh, they both have 3s and it's both the largest number, so that must be the greatest common factor. You have to multiply the common prime numbers at the bottom of the factor tree together. Okay? Questions on that? Yes.
We can go deeper into this later, or are we just gonna leave it at
This is what it's going to be. So if you have questions, now's the time to ask. Yes.
that? So what's the greatest common number?
Okay, so let's do an example of 32 and 64. The first thing you would do is start with 32 and find two factors. So I'm going to give me two factors of 32. Yes. 8 and 4. Is 8 a prime number? No. What are two factors of 8? 4 and 2. Is 4 a prime number? No. What are factors of 4? 2 and 2. Is this 2 a prime number? Yes, so I'm done. Is this 4 a prime number? No, so that goes to 2 and 2. So to get 32, I do 2 times 2 times 2 times 2 times 2. 5 2s. Okay? Let's do 64. What are factors of 64? 8 and who? What did you say? 8 and... Oh, sorry. I couldn't hear you. 8 and 8. Factors of 8? 4 and 2. 2 is prime. Factors of 4? Probably wasn't the best example to choose. This would be the same. 4 and 2. 2 and 2. So here we have 1, 2, 3, 4, 5. Okay? They both have 5 2s, so they're all, we count them all. What's 2 times 2 times 2 times 2 times 2? 32. Yeah, I shouldn't have chosen this one. Let's try a different one.
No, that one has 6 twos.
Which one?
64.
Oh, you're right. I'm sorry. I forgot about that guy. So this one has 5 2s. This one has 6 2s. Because this has 6, we're not going to count this one. When it's 5 2s and 5 2s would be the greatest common factor. Yes.
Why don't we ever do like 1?
We don't consider 1 a greatest common factor. Yes.
You just
All right, so our third method is birthday cake factorization. Now, this one is probably the newest for all of you. So the first step is to make a birthday cake for a given number using prime numbers. So, for example, first, you want to make a list of prime numbers. So they start, and this might be easier if I do it this way, so we're not looking at so much. So before you start, you make a list of prime numbers, 2, 3, 5, 7, 11. So those are our initial prime numbers. Those are the ones you're probably going to use. Second, you're going to build a cake using prime numbers as divisors. You can start with 1. Okay? So you have 2. What's that say? I'm going to pause it here. Okay, we're going to do the birthday cake with find the prime factorization of 64. So we have 2, 3, 5, 7, 11, 13, no, not 15, 17, okay? Yada, yada. So you start at 64. What is the smallest one you can do? 2. 64 divided by 2 is 32.
32.
And I can divide that by 2. 32 divided by 32 is 16. Divide that by 2. 8. Divide that by 2. 4. That wasn't a good one to do. 2. 2. 2. Candle. That's your 1. Okay? So your factor, prime factorization of 64 is 2 times 2 times 2 times 2 times 2 times 2.